This image should be impossible. A scanning electron microscope is supposed to image tiny samples, but somehow it's imaging its own chamber, and the reason is that electrons are literally bouncing off this plastic sphere. Normally electrons slam into whatever they hit. They don't bounce like a light from a mirror. But today I'm going to try to turn this small plastic sphere into something strange, an electron mirror. My name is Eric and this is my scanning electron microscope. On this channel we talk about microscopy and sometimes we put interesting things inside the SEM and explore the micro world. Let's think about what normally happens inside a scanning electron microscope. An electron beam is accelerated towards the sample with a huge amount of energy, sometimes 10 or even 30 kiloelectron-volts. When the electron beam hits the surface, it interacts with the atoms in the material. These interactions release tiny signals like secondary or backscattered electrons, which the microscope detects to build up an image. But something strange happens when the sample is an insulator like a plastic sphere. When the electron beam hits a dielectric material, the electrons cannot easily flow away because the material doesn't conduct electricity. So instead the surface starts accumulating charge. Over time this builds up a negative electrostatic potential on the surface. Now remember, every electron in the beam has kinetic energy, which depends on the accelerating voltage of the microscope. For example, at 30 kV the electrons have a lot of kinetic energy, so they can still reach the surface. But when we lower the beam energy to something like 1 kV, the electrons become much slower. And if the electrostatic potential of the charged surface becomes larger than the electron's kinetic energy, the electrons simply cannot reach the surface anymore. Instead, they slow down, stop, and then reverse direction. They literally bounce back. This creates what's called an electron mirror. Instead of hitting the sample, the electrons are reflected by the electric field above it, and that's why the microscope can start imaging things it normally never could, like the inside of its own chamber. In a way, the microscope is taking a selfie. And yes, it's pretty strange to see the secondary electron detector using the secondary electron detector itself. I also made a short time lapse. If we keep scanning the sample for a while, the accumulated charge gradually dissipates and the mirror effect slowly disappears. I actually came across this mirror effect by accident while making a video about a vinyl record. If you haven't seen it yet, go check it out. Thanks for watching and see you next time.